So where were we? We'll quickly recap from the beginning. Our aim to show that if R0 less than 1, Q star equal to 0, and to show that if R0 greater than 1, then Q star greater than 0. This was our aim. And then we found out a formula for Qn, which was 1 minus P Qn minus 1 to the power of k. But our aim is to find Q star, right? And we have defined a function, we have looked at a function, and the function was fx equals to 1 minus px to the power of k, and we have looked at that this Q star is nothing but f of infinite times 1. And this is the value which we are after. We need to find out what is this value. Let us see how do we find this value. So what all we are having? We are having f of x, which is 1 minus px to the power of k. This is our f of x, and our aim is to find f of infinite times 1. How do we find it? First of all, let us analyze what is this function. How does this function look? Let's see how will this function look. So let's try to find f of 0. What will f of 0 be? It will be 1 minus 0, right, which will be nothing but 0. So f of 0 is 0. And let's look at what is f of 1. F of 1 is 1 minus p to the power of k. And we know that p is something positive. So this entire value is going to be less than 1. So f of 1 is something which is less than 1. F of 0 is 0 and f of 1 is something which is less than 1. Let's try to see how will this plot look like. So I draw a plot here. Let's say the y-axis and x-axis, and here it is here it is 0, 0. And I first of all I draw a line also here, and this is a line. I say, what is this line? You all know. So this line is y equals to x, and this point is 1, 1, right? And let's see how will our function f of 0 look like. Our function f of 0 is first of all having a point here for sure, because at 0 f of 0 is 0, and we know that f of 1 is something less than 1. So this point is f of 0, and f of 1 is going to lie somewhere here which is less than 1. So this point is f of 1, f of 1. So this point is 1, f of 1. Okay, we have seen the starting point of this function and the ending point. What happens during middle? What happens here? How does this function look like? And that's also easy to calculate. Let us see how can we calculate that. Let's try to find out the slope of this function at this point. Let's try to find out the slope of this function at this point. So what is this slope? This slope we know is 1, right? This slope is 1, which is your 45 degree, tan of 45 degree 1. So if at this point, so now see this function f of x can either go like this or go like this. When does this function go like this? When the slope of this function here is less than 1, right? If the slope is so, because this is slope equal to 1. So if this is slope equal to 1, if slope less than 1, then this function will go from downwards of this function y equals to x. And when will this function go like this? It will go like this when the slope of this function is greater than 1. So let's first try to find out the slope of this function. So what do we do to find out the slope of the function? Is to differentiate it. So we have the function fx equals to 1 minus px to the power of k. Let us differentiate it. So f dash of x becomes minus k 1 minus px to the power of k minus 1, right? Multiplied by differentiation of 1 minus px, which is minus p. So this becomes equal to pk into 1 minus px k minus 1, right? So this is the slope of this function, and we are interested to find the slope of this function at x equals to 0, at origin. So what is f dash of 0? F dash of 0 is pk into 1 minus 0 to the power of k minus 1, which is nothing but p into k. Isn't it amazing? The slope of this function is p into k. And what is p into k? If you remember, p into k is nothing but your basic reproductive number r0, from where we started and where we reached. So you see, we started off with this function f of x equals to 1 minus px raised to the power k, and then we try to plot this function, and this is the line y equals to one second, and this is the line y equals to x. This is the line y equals to x, and then we saw that here will be our point f of 0 and here will be our point f of 1, and then we were interested in finding the slope of this function at this point, and it turned out that the slope of this function at origin is nothing but the value of the basic reproductive number. So just remember all this. We have this f of x here, and this function looks something like this, and we wanted to find out f of infinite times 1, and then we tried to look at this function. The function turned out something like this, and then we saw something amazing. We saw that the slope of this function at origin is nothing but r0. So now we'll see for different values of r0, that is r0 can be less than 1 or greater than 1. How does this value, which is nothing but q star, turn out to be? And that will be the end of this proof, which we'll do in the coming up lecture.